All right, this is pre-algebra lesson 10, rational numbers and equivalent fractions. So if we add any two whole numbers, is the sum a whole number? Of course it is. What if we multiply any two whole numbers? Is the product a whole number? Of course it is. So since every sum or product of whole numbers is a whole numbers, we say the set of whole numbers is closed under addition. So if we add two whole numbers together, we're going to get a whole number. So it's closed under addition. And if we multiply two whole numbers together, we're going to get a whole number. So it's closed under multiplication. A number has closures. When you perform an operation to it, you get that same type of number. So two whole numbers is going to give you a whole number. So it's closed. If we subtract any two whole numbers, is the difference always a whole number? It's not. We use counterexamples to prove statements false. Counterexamples are not words, but number sentences. A counterexample is a statement that proves a statement false. So, to prove that whole numbers are not necessarily going to give us a whole number when we subtract, what if we subtract 3 minus 5? 3 is a whole number, and 5 is a whole number. But if we take 3 minus 5, we are going to get -2. And -2 is not a whole number. It's an integer. It is not a whole number. Whole numbers, remember, are 0 and all the counting numbers. So this is a counterexample. It is a mathematical statement. It is it is going to be just numbers, not words. A rational number or rational numbers are positive and negative numbers, they're integers, whole numbers, and fractions that convert to decimals that either terminate or repeat. What does the word terminate mean? It stops, right? So fractions that stop, like 1/2, right? Or we can write 1/2 as 0.5, or 1/4, or 0.25. Okay? Those stop. It's a fraction that stops, that converts to a decimal that stops, or it repeats. Like 1/3 is 0.33333333. So it's 0.3 repeating. Okay? So those are all rational numbers. Are these numbers whole numbers, integers, or rational numbers? -3. Is that a whole number? Nope. Is it an integer? Yes. How about a rational number? Let's go back to our definition. Positive and negative numbers or integers, whole numbers and fractions that convert to decimals that either terminate or repeat. So it is also a rational number. 2, what is it? It is whole. It is an integer. And it is rational. Is 3/4 whole? It is rational, and it is an integer. I love it when my computer does those crazy things. So let's look at equivalent fractions. You look at this, these are all equal because they are 4 different ways to show the same shaded proportion. 1/2, 2/4 is the same as 1/2, 3/6 is the same as 1/2, and 4/8 is the same as 1/2. One way to find equivalent fractions is to divide the numerator and denominator by the same number. So 4/8, to make an equivalent fraction, we can say 4 divided by 4 is 1, and 8 divided by 4 is 2. 3/6, 3 divided by 3 is 1, 6 divided by 3 is 2. 2/4, 2 divided by 2 is 1, 4 divided by 2 is 2. So 4/8 and 1/2 are equivalent. 3/6 and 1/2 are equivalent. 2/4 and 1/2 are equivalent. You can also find equivalent fractions by using the factorization of both the numerator and denominator and canceling out the numbers they have in common. So let's do some prime factorization. So 72. We need to know factors of 72. What are factors of 72? Well, we can do the lowest prime number. We could do it division by primes. We know it's an even number, so we know 2 will go into it. We could also do 9 and 8. 9 is 3 and 3. Those are prime numbers. And 8, 2 is a prime number. 4, we got 2 and 2. Well, that's a lot of factors, isn't it? So 72 is 2 times 2 times 2. Got 3 2s, and 3 times 3. Now 108, we could do, let's do division by primes on this one. 2 goes into 10 5 times. 2 goes into 8 4 times. 2 goes into 54. So let's come over here. 2 goes into 5 2 times. 2 times 2 is 4. 2 goes into 14 7 times. 27. When we go to 3, 3 goes into 27. 9, and remember we're doing division by primes. They all have to be prime numbers. 3, 3, 1. Wait a minute. What did I do wrong here? No, that's right. I did nothing wrong. Ignore your teacher. She just had a crazy moment. 2 times 2 times 3 times 3 times 3. Ignore my crazy moment. Just ignore it. All right, so we're going to cancel out things they have in common. They both have a 2. They both have another 2. They both have a 3. They both have a 3. Then we're going to circle what's left over. A 2 in the top and a 3 in the bottom. So 2/3. We reduced that all the way down, and we found the equivalent fraction. 72 over 108 is equivalent to 2/3. Isn't that pretty cool? Oh, by using prime factorization. I said it, I just didn't hit the button. All right, another way to find equivalence fractions is to multiply the numerator and denominator by the same number. So we want to figure out 1/2 is equivalent to something with the denominator of 100. So 2 times what equals 100? 2 times 50, right? So if we did 1 times 50, our equivalent fraction would be 50 over 100 is equivalent to 1/2. 1/2 is equivalent to 50 over 100. So 3 times what is 21? 3 times 7, right? So 1 times 7 is 7. So 7 over 21, 7/21 is equivalent to 1/3. And then 6 times what is 30? 6 times 5, and 2 times 5 is 10. All right, there you go. Hope you got something out of this. See you soon. Bye.